Okay, for anyone who missed sections 9.2 on linear regression, I'm going to revisit these notes for you, explain the pieces of the puzzle, so to speak, and do the sample problems at the end so that you know how to do an equation of a regression line and making predictions. So here we go. I discussed this last week on Thursday. You saw this file open already, and the slide here at the top left shows something called a scatter plot with a line of best fit drawn on it. The reason we get to call this the line of best fit is because it minimizes the amount by which the observed data points kind of miss the line. How much the points miss the line, if you look at this second slide, these are called residuals. Each of these observed data points miss the line by a certain amount. So we have an observed y value minus a predicted y value called the residual. And the equation that we're about to derive for the so-called regression line or line of best fit involves the line which minimizes the sum of the squares of those residuals. Okay? So the line that we're going to derive has some symbols that go with it. We're going to use this symbol y hat equals mx plus b. So the only difference from this in algebra is that this is estimated from data, so we put a symbol y hat on it. It stands for a predicted y value for a given x value. Now the next couple of slides and some of the examples that follow show you that we can get the slope of the line of best fit with this formula that can be crunched out from the data, and the y-intercept of the line of best fit can also be crunched out from the data. X bar and y bar are the usual mean of the x and y values respectively, and the regression line will pass through that point. So that's a nice thing if you think about it. Sliding back up to the top here, if we could figure out the average x and the average y, the line of best fit is programmed to go right through the average x and the average y. Okay, so then the matching exercise at the bottom is just going to show you some symbols that were on the slides above, and we're attaching basically a word description to a symbol. So take a moment to check out how we matched the words to the symbols, and I'm going to flip the page. Okay, so on this page we have an example with a data set, and the x's are a country's GDP and the y values are carbon dioxide emissions. So if you wanted to get correlation and or a line of best fit, check out the slide to the right. You would have to multiply every x and y together, add it up. Square every x, add it up. Square every y, add it up. And from these totals that are in the bottom row of this chart, you can go play with these formulas for slope and y-intercept in the next slide. Don't worry, we are not going to make you do this complicated work by hand. We're going to show you some calculator commands at the bottom to get the so-called slope, 196.152 for the line of best fit, and 102.289 for the y-intercept of the line of best fit. Okay, if we're going to go sketch that regression line, all we would have to do is plot the y-intercept, use slope, and we could draw the line of best fit through the data points. And now the goal of what this line is going to do is it's going to give us a model from which we can make predictions. So if you wanted to tell me a country's GDP in trillions of dollars, that would be x. I could plug that x into this model, and I could predict that country's carbon dioxide emissions from the model. Well, anyway, to get that line of best fit, what's going to happen is you're going to go in your calculator, and you are going to go put these x's in list 1. You're going to go put those y's in list 2, and you're going to get your calculator to show you this screen if you press your stat button. Okay, so do that now. Use your list editor, as I said, to make list 1 list 2. Press that stat key again. Go to the calculate menu, and option 4 is called lin reg. Fill in the prompts for that command, and you will get a 4-line display that includes A, the slope, B, the y-intercept, r squared, and r. So R is correlation that we've already talked about in the previous section. A is the Texas Instruments symbol for slope. Do you see y equals ax plus b? And b is the usual symbol for y-intercept. Okay, I'm flipping to page 13 of your notes. Okay, so now here you can see the objective is to predict the y values using that regression equation. So on the previous slide we derived this for the regression equation, and now what we'd like to do is for countries that have these 3 GDPs, we'd like to plug the x's in, plug the x in, and predict the carbon dioxide emissions. Next, $2 trillion, plug it in, predict carbon dioxide emissions. Next, $2.5 trillion, plug it in, and make predictions. So now how useful is this line for making predictions? Check out this important paragraph at the bottom right here. If you notice that the data set had GDPs roughly ranging from 0.9 to 4.9. So if we make any predictions with x's in that range, we call those predictions interpolations and expect them to be pretty accurate. But if we put in a very small GDP like 0.2 or a very big GDP like 14.5, although there's nothing preventing us from making the predictions, we wouldn't expect them to be accurate or meaningful. So beware of extrapolations. All right, so I'm going to flip the page. And we're on the last page here, doing some exercises from class. So we filled these in today being Monday, May 1st. And what we were supposed to do here is match the equation for these lines of best fit, 4 equations to 4 graphs. And the way we did the so-called process of elimination was we noticed that 2 of the equations, 13 and 16, had negative slopes. 13's negative slope was -1, 16's negative slope was -0.6. This would be a steeper negative line than this, so that allowed us to deduce that this one was 13 and this one was 16. This one being a little bit steeper negative slope. And then the other two, 15 and 14, they have positive slopes. One slope is quite small positive, and one slope is 1.6 something. So you see this line's almost horizontal. It's number 15 with that small positive slope, while this line over here has a more steep positive slope. And then finally, the last exercise is to look at another data set to come up with the line of best fit with our calculator, and then make some predictions if they're meaningful, and draw the graph. So here's what I did first. I put the heights in list 1, that's the explanatory variable, also called the independent variable. I put the number of stories in the building in list 2, that's the y variable, the dependent variable, also called the response variable. And then after I made those lists, back to the stat button, the calculate menu, option 4 lin reg, run the prompts there, and out comes an A and a B for the line of best fit. So when you have to write the equation, that was the job, find the equation of the regression line, here it is. Y hat equals 0.065x plus 0.465. Here's the data plotted, and if you've forgotten how to make a scatter plot, I went and looked for the smallest and largest x, and they just happened to be first and last, helping me make my scale on the x-axis. I looked for the largest and smallest y value, helping me make my scale on the y-axis, and then I plotted those 9 data points as best as I could in the scatter plot. Okay, now it's prediction time. There are 4 predictions we're asked to make if meaningful. So the first prediction, I plugged 800 in for x, predicted if you have an 800-foot building, you have about 52 or 53 stories. If you have a 750-foot building, you have about 49 stories. If you have a 400-foot building, well, 400's quite a bit below the smallest building in the data set. That would be called extrapolation, leading to a not meaningful prediction, so we didn't bother with that one. And then finally in part D, you can have y hat equals 0.065 times 625 plus the 0.465. Crunch that out, you have about 41 stories. Okay, and then finally, you'd be asked to draw the regression line onto this plot. So I can imagine that these predictions gave me two ordered pairs, 800 paired with 52.5. And then let's use 625 that paired with about 41.1. So we could go over to 852.5 and place a dot. And then we can go over to 625 with a 41 and place a dot. All right, and then we can take a ruler out and we can draw a line of best fit. I guess I'll get a new color, blue, and I will attempt my line of best fit through those points. Okay, so that ends the lesson. Please look on my essay. There's a couple of homework problems for this topic. And Friday there is a quiz on this topic, sections 9.1 and 9.2. Hope this helped.